We're going to skip to 9.5 now, which is going to be graphing cosine and sine functions. So one thing that I do want to refresh your memory on is these different transformations that can occur to a function. Our goal here is to be graphing any kind of sine and cosine function, recognizing what the parent function would look like, and then also identifying any transformations such as shifts or stretches. So I think the best way to go about reviewing for this is just to do some of the problems. But one thing that I do want to go over is what do the parent functions look like. So the parent function of the sine function would look like this. And once you get the key shape, you would never have to do plot points like this, like what I'm doing with an XY table here. But just so you know that you could do this for every single point if you wanted to. So here I have down here sketched out some independent variables, which are the angles on my unit circle. So we have these angles here that we're going to be inputting into our sine function. The angle 0, if inputted into sine, so sine of 0, remember that sine is the vertical motion. So what is the vertical motion that I have to get or use to get to this point from the origin to this point? Where there's horizontal movement, but there's no vertical. So the sine, or in other words the vertical motion, is just 0. So what is the sine of pi over 2? If you inputted pi over 2 in for our independent variable, well, that's just going to be 1. The second key point is going to be just this pi, and what you are going to notice is the key points are happening at the quarters of our unit circle. So basically we take our whole period or our whole cycle and quarter it. So those are where all of our key points are. The sine of pi is once again going to be 0. And then we have 3 pi halves, which is going to be -1. And then we have back to 2 pi, where our period or our cycle would start repeating itself again. So this one's just going to be 0. So I'm going to start plotting these points. I have 0, 0. I also have, I would go over pi halves on my independent, and then my dependent was 1. Back to the 0, down, back up. What you have to realize is you could go ahead and start rounding the circle again. So we have 0 pi halves, 2 pi halves, which is just pi, 3 pi halves, 4 pi halves, 5 pi halves, 6 pi halves. But what's going to happen is it's just going to start repeating itself. Okay. Same thing if you went backwards. We're going to get this continuation of this flow, and that's what we call our sine curve. Okay, so this is the main, this is the main shape right there, and this would go on forever. Okay. All right, we're also going to do the cosine of x graph. So once again, here is my xy or my xy coordinate grid. Here are my independent variables, which are the angles that I'm concerned with. And then what do I get as the cosines, or the horizontal values of all of these angles? So when I look at my start, which is just going to be at this very start of the angle 0, what is the cosine of that? Well, that's going to be 1, because that's the horizontal movement. At pi over 2, this first key point, besides my start point, is going to be 0. When I go to pi, it's -1. I'll be going over 1, and once again this would circulate and continue to repeat that pattern over and over again. So I'm going to plot 0, 1. I'm going to plot pi halves at 0. And this right here is our cosine curve. And this would continue in that flow forever. Okay. So here is what that parent function's cosine would look like. So what we're going to be doing, I'm going to drag back on my sine function. That was the sine. So you can kind of see cosine is just you could write it as a shift of sine. But there are our two parent functions, and what we're going to be doing is applying all these transformations onto these graphs. So what could happen is, I'm going to just focus on my cosine. Alright, so here is my cosine function. What might be happening to this is there might be some sort of vertical stretch. Okay, so there's some sort of vertical stretch. It's where instead of going up to 1, it's going to go higher than that. All right, but we're still based around that midline. There might be a vertical stretch and a horizontal stretch, so what happens is something like this, like where our period will not any longer just take 2 pi. It's going to be something else. So here was one full period. It happened in 2 pi. I mean, it might stretch out and take longer than that. It might do something like that, or it might shrink. Okay, so we're going to be dealing with all these different types of transformations that can occur. I am going to go ahead and write these up for you, and there are some certain instead of calling them vertical shrinks and stretches, what we do call it is amplitude. So that first slide that I had up here, it was listing all those transformations and what they typically look like. When you multiply something onto the whole function, not just the x, so you have a multiplier not just onto the x, it's on the outside or onto the sine or cosine. What we call that, since it's not on the x, is a vertical stretch or shrink. Okay, we also call that amplitude. Period will be affected by a horizontal stretch or shrink. Period will be some sort of multiplier directly onto the x. So you'll have sine of maybe b times x or something to that nature. So it's also divided. If you divide something by x, remember like x divided by 2, that's the same thing as 1/2 x. Okay, so anything that's directly multiplying onto the x is that horizontal stretch or shrink. If you're adding something directly onto the x, it has to be in parentheses with the x. So adding or subtracting onto the x, it's a horizontal shift left or right. And keep in mind that x is a tricky, it's the opposite of what you would think. And then if you're adding something that's outside of those parentheses, not with an x, there's no parentheses, and there's just this plus going on or minus going on, that's going to be a vertical shift, and it's exactly what you would think. Alright, so one key thing that I'm going to be calculating is period and key points. Now, those are going to be that start x, y coordinate grid. I need to figure out what should I go by when I draw my coordinate grid. So remember when I had 2 pi, and then I had pi, and then pi halves. When we were graphing the parent functions, this is what it would look like. But we have to keep in mind this might not always be the case because we might have a different period because of some sort of horizontal stretch or shrink. So the period will be calculated by our typical period divided by b. So an example is if I had sine of 2, let's say 2x. All right, here we have some sort of multiplier directly onto the x. We know that that's going to, because if you go up here, what we're saying is that's a period change. It's some sort of horizontal stretch or shrink. So what we're going to do is take our typical period, which for cosine and sine, typical period is 2 pi. So when we're looking at something like sine of 2x, if I wanted to figure out my period, my modified period, well, it's going to be 2 pi divided by 2, which is equal to pi. What that means is instead of taking a whole 2 pi in order to complete my sine curve, it's only going to take up to pi. So the other thing is to find those key points. To find your key points, you always, or your key point interval is what I will be calling it, you will take whatever your period is that you calculated, so in this case pi, and you're going to quarter it. Okay, so you're going to take your modified period, whatever that was, and you're going to quarter it. That's how you find your key points. So let's do some of these. Number 1 is y is equal to 3 sine. Okay, so they even give you a little sketch of this, but that's not really my concern. You should be able to either visually see it, or you should always be able to algebraically calculate it as well. So I'm going to just start to list out the most important thing is being able to find your period, because that's what's going to help you graph it. So a period, once again, will be, since it's sine, the typical period that it would take to complete one full cycle is going to be 2 pi. But then, because we have something being multiplied onto our x, so it's directly onto our x as a multiplier, we're going to divide by that b. So it's our original period divided by b is how you find that modified period. Okay, so our full period is going to be pi. Okay, and then the key point interval for this would have been pi over 4. Okay, it doesn't actually ask for that, but it did ask for period, and then it would ask you for amplitude here, and then amplitude is, remember, going to be some sort of vertical stretch or shrink, and that's when you multiply something onto the whole function, not just the x, it's the whole function. So amplitude here would be 3. One thing that I will just note here quickly is if the amplitude is ever negative, or I'm sorry, amplitude can't be negative because the amplitude is the distance from the center line to the highest point. So since it's a distance, it can't be negative. But if you're looking at something that's a negative multiplier onto the whole function, well, you have to realize it's a flip and it's a a vertical stretch. The other one that I wanted to look at was number 39. So skipping right down to 39. They give me why they want us to graph this, and it says include 2 full periods. The first thing that I'm going to calculate is my period. Period would be my typical period, which is 2 pi divided by b. And what you have to see here is that there's this huge multiplier onto the x. 2 pi thirds is what's being multiplied to my x. So I'm going to have to divide 2 pi by 2 pi thirds. Okay, so simplified out, that's going to be 2 pi times 3 over 2 pi. These cancel each other out. My period is 3. Now, the key point intervals are going to be determined by when I quarter my modified period. So 3/4 is the key points that I'm going to go by. Amplitude. All right, so amplitude here is 1. All right, it's going to go from my center line up to 1. There is also that negative there, but keep in mind amplitude cannot be negative. However, there is a flip. So I'm going to just notate that with my amplitude. And it is, because it's not directly attached to the x, it's a vertical flip. So it's like you're going to grab your shape, my function shape that I'm going to be doing, and then flipping it over the x-axis or vertically. So there's no shifts, there's no other things going on here, so I'm going to go and graph this. I do need to graph at least 2 full periods. So I'm going to start right here. This is my full period. All right, I'm going to quarter it. Okay, so I get 3/4, and then I get 2 3/4, which is 6/4. I'm not even going to simplify this. And then I'm going to get 3 3/4, which is going to be, this is 1 3/4, 2 3/4, 3 3/4, 9/4. And then this would have been 4 3/4, which is 12/4, which simplified would be 3. This right here is going to be 1 2 3 4 5 3/4, so 15/4. This right here, and I had 1 2 3 4 key points for one period. I'm going to need 1 2 3 4 more. So let's see, 6 3/4 would be 18/4. 7 3/4 would be 21/4. 8 3/4 would be 24/4, which I hope you would see is 6. So it would make sense that 2 full periods would be completed over the space of 6. So I'm going to graph this, and I know because of that amplitude I need to go up as far as 1 and down as far as -1. And there's also a flip, so typically sine with the parent function starts at the center on my center line, which is on the x-axis, and then it would reach to its highest point, but because it's a flip vertically, I'm going to go down instead. So here is what I have. All right, another one that I'm going to do is number 41. So for 41, what I'm going to do is first calculate the period again. And this one is going to be 2 pi divided by, well, there is no multiplier to it, so technically it's 1. So I just have to know that my period is 2 pi like normal because there is no modifier, there is no horizontal stretch going on here. And then therefore my key points, just like the parent function, is going to be 2 pi and then quartered. So when you look at that parent function up at the beginning of this video, you will notice that I did go by pi halves. All right, there is no amplitude change, so I mean amplitude is just going to be up 1 and down 1 from that center line. There is this subtraction of pi force, so I do have a horizontal shift, and it is the opposite of what you would think. Instead of going back like you would think, it's going to go to the right pi force. All right, so there's a couple ways to do this. I'm going to go ahead and do the typical number line for what it would have looked like had I not had a shift. So I'm going to start at 0 and then go up to 2 pi and then quarter that. Okay, so normally my start would be on 0, and I know I would have 1, 2, 3, 4 key points, and they are going by pi halves. 2 pi halves, which is just pi, 3 pi halves, 4 pi halves, 5 pi halves, 6 pi halves, which is going to be 3 pi, 4 pi halves, 7 pi halves, and then 8 pi halves, which is just 4 pi. Okay, I did simplify it this time. So the idea with this is we need to take into account that all of our points instead now are going to be shifted to the right pi force. So all of these points have to have an additional pi force onto them. So I'm just going to, you could find these exact values, and the way you would do that is my start point would have been 0, but I'm going to have to add a pi fourths to it. So it's going to be pi fourths. My first key point would have been pi over 2, except for I need to add a pi fourths to it. So you'd need a common denominator. I'm going to have to multiply top and bottom by 2 here, so I'm going to get 3 pi fourths. So this is one way that you could do it. Instead, this is going to be my new key point, pi fourths. This right here is going to be 3 pi fourths. This point right here is going to be between those, and I'm just going to start adding. I'm just going to start adding what I know is my increment, so pi halves, or in other words, this is also equal to 2 pi fourths. So I'm just going to keep adding 2 pi fourths onto these. I have 5 pi fourths. I have 7 pi fourths. 9 pi fourths. So what you can go ahead and do is transfer that down, and if you have an eraser you could just erase this, otherwise you can keep it, but then transfer just this line down here, because now what I'm going to do is I'm going to draw in my y-axis, and this is a sine once again, and what sine does on the start point is it starts on the center line. Okay, so we have starting on the center line, and then here I know my amplitude is going up as far as 1, and then down as far as -1 goes, and then up, center, down, center, up, center, down, down, center. And there is now my shifted just slightly to the right sine function. Oops, sorry, I screwed up again. Alright, 50, and then I'm going to be done. So 50 looks something like this. We have y is equal to 4 cosine x plus pi over 4, and then plus 4. So when we're looking at this, there's pretty much everything going on except for a period change. So period is just going to be 2 pi. Key point intervals are going to be 2 pi divided by 4, so our period quartered, and that's just going to be pi halves. I do also have a shift to the right. Oh, nope, this one's to the left this time. Horizontal shift. I have an amplitude this time, which is 4, and I also have a shift up, a vertical shift, 4. So I have to do all of this now. I'm instead, just based off of what I did in this one up here, I'm going to instead just understand that when I graph my typical key point intervals for my function, what I'm going to do is actually go in between them because of this shift. So here I'm going to do this kind of top heavy, and you'll see why. Okay, so it was a shift to the left, pi over 4. So I am going to use this side of my x-axis. So negative pi halves. This is my 0. Here's pi halves. Here's pi. Okay, so here what I have taken into account is my period and my key points. My horizontal, I'm going to, instead of starting right, this is cosine now, so typically I would have started up at its maximum, that amplitude of 1, my amplitude, but instead of starting at 0 for that, I'm going to be starting at my amplitude right here, and I'm going to be using these in-betweens because of the shift. So I kind of have that covered. The other thing I need to do is shift up 4. So I'm going to do 1, 2, 3, 4, and what I'm going to do is redraw in my new center line. That's my new center line. It's no longer here. So I'm going to be working off of this, and my amplitude is 4, so I know I also have to go up 4 from that center line. So now, what used to be down here is going to be up here, and what used to be on the 0 for my start is going to be shifted back. And cosine starts at the maximum, or at the amplitude. So I'm going to start up, go down to my center line. This would have been my second key point. My third key point is going to go down 1, 2, 3, 4. So down, way down here. And then up to my center line. Using my in-betweens, I'm going to go up to my maximum, back down to my center, down to my minimum, back up to my maximum, or my center, and then up to my maximum. So here is that cosine function that's been stretched vertically. Whoops. It's also been shifted vertically, and it's also been shifted back, and there's 2 full periods right there. That's it.